Routing Information Protocol, also known as RIP, was one of the first distance vector protocols proposed for use on the Internet. Most of its popularity is attributed to the fact that it is the easiest routing protocol to configure. Now the flip side of that is that because of its ease of configuration, it is also the least flexible. In this nugget, we're going to look at the basic setup on how we globally activate RIP on the router and how we allow individual interfaces to pass routing updates. Then we'll use the monitoring commands to verify RIP functionality not only in our routers but across our network. And the redistribute command will be used to show how we can pass non-RIP routes over RIP updates from one router to another. And then we're going to end up with a look at how we can limit broadcast traffic and bandwidth usage by sending unicast updates instead of broadcast updates with our neighbor command. RIP is advertised as being very easy to configure, right? Holding to that idea, there are only two commands needed to actually start your router processing RIP updates and actively participating in a RIP network. Those two commands are the router command and the network command. Before we get into the particulars of each command and what it does, let's take a look at our network diagram so we can see that what our objective will be in activating RIP. First, I'm going to have a host, N1, that is on the network 192.168.1.0. Its particular ID is .254. All right, it's going to be connected to router R1. In between router R1 and R2 is the network 192.168.2.0. R2 and R3, there is a network in between those two routers, 192.168.3.0. And then finally, on the other side of R3, we have the network 192.168.4.0. Our objective will be to get RIP to the point that we have convergence in our network. Remember from earlier discussions, convergence is the point to where any router in our network knows of every other network involved or that can be routed to in that network. All right, let's take a look at our commands. The first one is the router command. It's going to be followed by a keyword that identifies what routing protocol we want to activate. So it could be router RIP, it could be router IGRP, router EIGRP, and you get the idea. This one command here is going to be used to globally activate a specific routing protocol on our router. Now, when we say globally activate, that means it is ready to be turned on any interface on that router that you would like. So now we have global activation. How do we specify which interfaces we want to participate in this RIP routing protocol? And that we do with the network command. The network command is going to be followed by an IP address, actually a network address, and that network address might encompass either just one interface or a number of interfaces if we're using IP classless in our router. In other words, we have subdivided a network ID to represent IP subnets on 3 or 4 interfaces, and we identify a network here, then that might activate RIP on 4 different interfaces. All right. Keep in mind that this network command is class-based. By that I mean, if you enter a network of, let's say, 10.x.y.z, because that 10 network is a Class A network, when we're looking at classful address spaces, it is automatically going to take an 8-bit mask. If we interject a 190 in the first octet, then that is going to be a Class B address, and a 16-bit mask would be associated with it automatically. Let's say 192, a Class C address, 24 bits. You remember that from our earlier discussions on different classes of addresses. Let's take a look at both of these commands in action on our router. First thing we're going to do is gain access to that router, as we always do, by typing in the password, use the enabled command to get into the privilege mode, and once we're in there, we're going to config from terminal. All right, the first command we have here is router. Let's type that in. This is going to globally activate a specific routing protocol. I'm going to use a question mark, as I just did, so that I can show you the examples of what we can activate. All these routing protocols are available. We're going to use RIP for the purpose of this nugget. All right, so router RIP, and that's all you need. At that point, you have router RIP running on the entire router. Now let's use the network command to specify the individual interfaces that are going to participate in this routing protocol. And we're going to do that with a network number here, 192.168.1.0. And then we're going to use another network number, network 192.168.2.0. All right, once that's done, let's get out of this configuration. And what we want to do now, once it's done configuring from console, is look at the changes we just made within the config. I'm going to expand this so that we can see it better. All right, and then we're going to get to the point that we see the information that we want. Here it is. Router RIP is activated. Specific networks that we're going to use are 192.168.1.0, 192.168.2.0. The reason for that, we have two interfaces that are active on this router. The first is interface E0, Ethernet 0. Its IP address is 192.168.1.2, but the network associated with that interface is 192.168.1. And here we're going to see interface serial 0. The 192.168.2.0 network is associated with this interface. That's why we activated both of these statements on the individual networks. Had we just done the top statement, 192.168.1.0, then this would be the only interface that is effective and therefore participating within RIP. All right, let's go back to our slides and take a look at the three things that are going to be the result of a network command. They are route updates are sent out of that interface. All right, that makes sense. Another, the local subnet address is in those updates. All right, so if we activated the interface 192.168.1, we're going to send routing updates out of this interface, and at the same time, we're going to advertise this network in those updates. We're also going to listen for updates that come in through that interface. Now, because we have two that are activated together, when we advertise outside of this interface, it's going to have this network in it and this network. And when we advertise in this direction, it'll have both networks as well. And we're going to see that as we use our monitor commands to verify functionality of RIP in our network. Almost as if by design, there are only two commands needed to configure RIP, and there are only three commands needed to really effectively monitor RIP and make sure it's running as it should be across your network. And those three commands are, first of all, show IP route. This command you're used to and you've seen before. Specifically, though, this time we're going to be looking for routes that are learned and marked by an R, which means they're learned by the RIP routing process. The next command we're going to use is show IP protocol. This command is going to show us every routing protocol that is running on that router. Examples, IGRP, EIGRP, OSPF, or RIP. We will get information on those protocols by using this command. We will take a more in-depth look at exactly each piece of information that we get out of this in respect to RIP once we get into our router here in a minute. The third command we're going to look at is debug IP RIP. Now, as you can tell, because we're saying debug IP in its base, there are other options here. We're going to look at specifically RIP, and what it's going to do is it's going to give us every routing update or any piece of information that is sent or received concerning RIP from our router. Now, keep in mind, if you have a large network, as with any debug command, this information can be a lot of information coming in, and it can overwhelm your screen. So be careful when you turn this on. For our network, it's pretty small, so it won't be too cumbersome, and it's actually going to give us a lot of good information as to what is going on behind the scenes in RIP. Let's return to router 1 now and see what information we can gather using these commands. All right, the first command, show IP route. Now, what we're looking for is any route that is learned and marked with an R because it's learned by RIP. That's what we said earlier. There are none now. The reason for that can be seen when we look at our next command, which is show IP protocol. The output of this command is a little bit lengthy, so let me make our window a little larger before we actually issue it. Here we go. Show IP protocol. All right, the only routing protocol running on this router is RIP. And the way we know that is, if there were any others, we would also see routing protocol is, underneath here, IGRP, EIGRP, OSPF, or any of the others that are available. All right, let's look at specifics that we see here. First of all, sending updates every 30 seconds. With RIP, it's every 30 seconds. This is very important that this amount of time between updates is standard with all the routers that are participating in RIP. And the reason for that is that you're going to get some anomalous type of problems in traffic if you don't. Don't venture out. Do this. Stay here. This is programmable, but don't change it because you never know when a new router is going to be interjected into your network by one of your assistants or somebody else that works with you, and then you're going to have differing update times. All right, it also tells you when is the next update due. In this specific case, it's due in 10 seconds. It gives you other timer information as well here. And very important down here, it tells you which interfaces are involved in the RIP protocol, Ethernet 0 and Serial 0. The reason for that, we activated these two networks, and they are on those interfaces. All right, why do we not have any routes when we show IP route? If we use that command, we don't see any routes that are showing with an R. because we haven't set up any routing information sources. In other words, we have no other router that we're trading information with so that we can learn other routes. And that's why all we have is in our routing table these two up here, directly connected networks. Our third monitoring command is actually the most fun, and it is debug IP RIP, because you get a real-time look at exactly what is happening on your network and what is being transferred from one router to another. And in some cases, you might find that you have something that you need to tweak to make it work a little bit better. Okay, so we've turned on our debugging of RIP. Now we know that we're only going to send updates every 30 seconds. So at a maximum, we would have to wait here 30 seconds before new information pops up. So it should be coming any minute, actually any second. And there we go. All right, RIP send out version 1 update to any address out there on the wire. It's a broadcast address out of Ethernet 0. And what it broadcast or it advertised was network 192.168.2.0. Okay, when it sent an update again to the broadcast address out the serial interface, it only advertised network 192.168.1.0. The reason for that is it's not going to advertise out of an interface the network that exists there. So the network 192.168.1 exists on this interface. It's only going to tell you about .2. .2 exists here. It's only going to tell you about .1. Note that so far, all we've done is sent updates out of this router, but we haven't received any from any other router. Again, that is because we don't have any information sources that we've identified as giving us RIP information. It doesn't keep us from participating in the protocol and advertising out of our interfaces, but it does not allow us to gain any information as far as other routes that exist on the network. So let's set that up. Let's go to router 2. Actually, let's shut this one down first. We're going to go to router 2. Gain access. Let's see here. And get to the correct mode so we can get into our configuration mode, config T. And we're going to use our command router RIP first. And then we're going to identify networks to participate. And because of our diagram, we remember that 192.168.2.0 is one interface on that router number 2, and the other interface is 3.0. All right, now we have RIP set up. Let's take a look at what we've done within the config. And this is a bit longer config, so it takes actually a little bit longer to get there, but here it is, router RIP, these networks, 2.0 and 3.0 on the 192.168 address space, and we're ready to go. All right, show IP route is going to give us our first route that we've learned via RIP, and it tells us that 192.168.1.0 exists if we go to 192.168.2.1, which is router 1's interface on our 2 network, which is the shared network. And that's the only route that we know of so far, and in fact, when we looked at the other router earlier, that's the only route that it's advertising. So that makes sense. We've gathered all the information we can. Let's take a look at show IP protocol on this router. Open our screen more. All right. Update every 30 seconds, just as we saw on the other router. Other timers here. Next update is due in 27 seconds. We see the interfaces that are involved. In this case, 2 serial interfaces because of the networks that we activated. And now, here's the new information. Routing information source. It lists router 1's IP address, 192.168.2.1. And it tells us that its default distance is 120, and it tells us the last time that we received an update from that specific router. Now, if we go back to router 1, we're going to see that same information, except in reverse because the information source will now be router 2 for router 1. So let's check that out, show IP protocol. There it is, 192.168.2.2. Default administrative distance is 120, last updated 12 seconds ago. All right, let's take a look at our slides so we can see what we've done so far. We've taken router 1 here, and we've activated RIP for 2 interfaces. We've taken router 2 and activated RIP for 2 interfaces as well. The only RIP network that we've learned about on router 2 is this network here, so it's passed across. And if we go over to router 1 and administer a show IP route command, we'll see what we've learned from router 2. So let's do that. All right, there we have it. learned from RIP, 192.168.3 exists on the other side of 192.168.2.2. So let's go back to our diagram, exactly what we thought. This network exists to router 1 now as long as we go to this interface. 2 routers down, 1 more to go, because remember, our objective is complete convergence on this network. So let's get into router number 3 now. Gain access. All right, we're going to configure from terminal. First command, router RIP. Globally set it up. Then the network command. The interfaces here are 192.168.3 on one side, 192.168.4 on the other side. So I'm going to do something here. I'm only going to activate 192.168.3.0. And then let's see what happens. Let's show IP route. All right, automatically, it was pretty quick, wasn't it? We know and we learn about 192.168.1.0 as long as we go to 192.168.3.1, which is the interface on the router 2. All right, and we also know that .2 exists. I'm sorry, 192.168.2 network exists on the other side of that router as well via RIP. Let's look at the updates that are coming across, though. This is going to be interesting. We're going to use the debug command to do that. All right, it's on. What we're going to see is we're going to see the packets that we receive from router 2, and we're also going to show that instead of transmitting a packet out of our interfaces, and the interface we've activated is 192.168.3.0, which is directly connected to router 2, instead of sending information down that pipe, we're actually going to send and suppress our update. And here we see that. Let me turn off the debug. You do that with a no debug all, by the way, and it turns off any debugging that exists on your router. All right, we see that we received an update telling us of the 2 routes that we learned, but we also see here sending version 1 update to anybody via serial 0, which is that network, but we're going to suppress it because it's a null update. That means I don't have any information to provide router 2 about any network that I have. You know, he knows everything that I know, so there's no reason for me to clog up the pipes and send this out. So it's not going to do it. It's going to suppress a null update, which is pretty cool and shows a little bit of thinking within the RIP protocol so that we can conserve on our bandwidth. Before we leave this router, though, let's test convergence or connectivity across our network with a ping to 192.168.1.1, which is the interface on router 1 facing the other side from router 3. All right, and there we go. We have 5 responses to our pings. That's how easy it is to set up RIP and get convergence. If you recall, in our earlier nugget, we talked about manually setting up routes using static routes and default gateways, and it was a lot more work. Think if this network was much larger in scope, much larger in size, the time and the work that would be saved with this routing protocol. So far in this nugget, we've looked at the commands associated with the basic setup of RIP, and there were 2 of them. We also looked at the commands for monitoring the functionality of RIP throughout our network and on our routers. Next, we're going to look at how do we redistribute routes that are learned from either other routing protocols or static routes across our network inside of routing updates from RIP. For our example, we're going to redistribute static routes. Here we go. What we're going to do is we're going to go on to R3, router 3 here, and we're going to put in an IP route, a static route saying that the network 10.1.1.0 is available through 192.168.4.254. Now that's the interface on N2. So what we're doing is we're telling router 3 that this box is actually dual homed, and on the other side of this dual homing exists this network. All right, so we're going to do that on router 3. After we do that, we're going to type in our redistribute command. And there's a lot of options available. We can redistribute for any routing protocol that is active on our IGP side. What we're going to do this time, though, is we're actually going to redistribute static. And that's how simple it's going to be. So let's go ahead and do that. Going on to router 3, let's get into the config mode and set up our IP route 10.1.1.0. The mask is 255.255.255.0, which is a 24-bit mask. And you get there via 192.168.4.254, which is N2. All right, now that we have that set up, let's get into router RIP. Note here, I couldn't just type in redistribute static at this point because it's a command that wouldn't be understood because we're in the config mode alone, the global config mode, and this command isn't available there. So I go into router rip, and now that I'm configuring the router, I can do the redistribute. And we are going to redistribute static. All right, there are other options available. In fact, I'll show them to you. You can actually put in here the metric for every static route that you distribute down to the next routers, and you can also set up route maps. But for our example, we're just going to go ahead and hit enter here, and let's see the result. We'll end our configuration session as we did before, and what we're going to do is debug IP rip. Okay, what we're expecting to see different this time is instead of the suppressed route going out, we're going to see an advertisement now for the network 10.0.0.0. Now, why is that different than what I put in? Here I put an IP route in for 10.1.1.0 with a 24-bit mask. Remember, the RIP operates on a class basis. Let me turn off debugging now that we got what we're looking for. Operates on a class basis. So it's not going to tell me that network 10.1.1.0 with a 24-bit mask exists out a certain interface. It has to tell me that the 10 network, the entire network exists out that interface. So, use some caution there. If you have different parts of the 10 network subnetted into different subnetworks and they exist on different parts of your network, be careful what you're distributing across that network because you might add some confusion to a route table. Let's say on R1, by the time this route gets there, if we had a route to the whole 10 network pointing one way and a specific network pointing the other, there could be some routing complications. Let's get into router 2 now and make sure that it's updated its tables correctly. All right, let's gain access. Okay, show IP route, and we should see a route for the network 10.0.0.0 as we do here. So we've made it halfway across our network. Let's verify now on router 1 that we see here that it made it across the entire network, and indeed we have convergence. And here we see learned via RIP, the network 10.0.0.0 is available on the other side of router 2. This is the interface on router 2. So as you can see, the redistribute command is the key to allowing many routing protocols and static routes to operate on the same network simultaneously and in a complementary fashion so that you can achieve convergence. And it passes that information via RIP through these routers. All right, the next thing we're going to look at is the neighbor statement. Its main use is to conserve bandwidth. What it does is router 1, under normal operation in RIP, will send out a routing update to this address, 255.255.255.255, which is the broadcast address. And we saw that when we were doing our debugging. With the neighbor statement, we would tell router 1, hey, router 2 at IP address 192.168.2.2 is your neighbor. We'll also tell router 2 that router 1 at IP address 192.168.2.1 is your neighbor. So now the resulting updates that come out, instead of being sent to the broadcast, are going to be from one MAC address to another, identified through the IP address, just like this directly and like this. You can see in a large network environment how much bandwidth that has the potential to save. Let's start off by configuring router number 2. I've already gained access and I am in the privileged mode, so I'm going to go into configuration via terminal, get into router RIP so that I can set up the neighbor command and type it in. Your neighbor is going to be 192.168.2.1 because we're pointing it at router number 1. Get out of that, go over to router 1 and do the exact same thing. Okay, get into config mode. Sorry. And router RIP. Now we set up our neighbor, which in this case is going to be 192.168.2.2, pointing at router number 2. All right, once we have that done, we're going to set up the debug so that we can verify exactly what's happening and the changes were made. So debug IP RIP. And what we're looking for this time is not the directed broadcast, but we're looking for the individual unicast sent message from one router to the other. We will see a directed broadcast out of the other interface, that other Ethernet interface on this router. But as far as the serial updates, like we see here, we're going to receive an update from 192.168.2.2 that's directed directly at us, and it is here too. And now we should see one that we send to that address. All right, sending out the Ethernet interface, it's a broadcast. But here, sending out to that 2.2 address out of serial 0, advertising 192.168.1.0, you can see this is a unicast. Let me turn that off. And that's what we have. If we wanted to, we could also say that out of the Ethernet interface, we have a neighbor that we want to communicate with and make this a directed unicast packet rather than the broadcast. In this nugget, we saw that the basic commands needed to set up a router to operate in a RIP environment are only two, and it's router RIP and also the network commands. We also learned how to use the show IP protocol command to see the exact configuration of RIP in our router, and we looked at the debug IP RIP command to see the exchange of routing updates between our router and the next routers down the line. And the last monitored command was the show IP route command, and this showed us the dynamic routes learned via RIP on our router. Then the redistribute command was shown as the vehicle to use to advertise non-RIP routes over RIP routing updates. And the last thing we looked at was how to limit broadcast traffic using the neighbor command so that one router would be aware of the interface of its neighbor and be able to send routing updates directly to that neighbor via unicast packet instead of broadcast. I hope this has been informative